video, okay? I'm sorry if the elementary row operations for the REF and RREF, or REF and REF, was a little bit complicated. It's supposed to be. So when I come back, I'll clarify anything that you don't understand, okay? But let's try one, okay? Now, I'm going to give you instruction for this, okay? It says, I'm going to say, this is a linear system, isn't it? So we're going to solve this sucker using Gaussian. Right now, we're just doing Gaussian. There's something else that's called Gaussian-Jordan elimination, which we're going to tackle later. Gaussian elimination is actually changing things to REF form, okay? This is going to require back substitution, and I'll explain all that while we're working on it right now, okay? So we're going to solve this sucker using a Gaussian elimination to make it into an REF form using back substitution in the end. So that means our goal is to make 1, 0, 0, something 1, 0, something, something 1, and then hopefully there's some values here. That's our goal, okay? So you'll see what I mean by the X's there, okay? Remember, but leading ones are always ultimate goal, okay? So I'm going to try your book, notations, okay? But later I told you we could do it the lazy method. Don't tell Mr. Paul. All right, so you guys, we've transformed this linear system into a matrix form, haven't we? And I'm just going to add a dotted line here because this is an augmented matrix, okay? All right, now let's actually start by writing the original. Let's write the original. But let's see what we're going to do. Now, is there anything that you want to, like, maybe row elementary, like following the rules? Is there something that you want to switch? Because remember, your goal is to have a leading 1. Yes! This guy here is beautiful, isn't it, okay? So I would suggest that we swap those, okay? So I'm going to write here. Okay, I'm going to say row 2 becomes row 1. Okay, does that make sense? So that means 1, 2, negative 1, 3, and row 1 just becomes here. Negative 5 and 14. And this means row 1 became row 2. Okay, that's how row 2 was formed. Okay, and then the third row, we didn't do anything to it, so we're just going to leave it alone. Okay, all right. All right, we're ready to start. It's going to be a little lengthy, but we're going to be okay, okay? All right, now what should I do, right? So I'm going to move it down, okay? Now, you guys, we have our ultimate goal here. Don't you guys want to get rid of this sucker here, and this sucker here? And you're thinking in your head, what do I need to multiply to this guy to get rid of this guy? If I add it together, they must disappear. So you're right. We need a negative 3 to be added here. Don't look at anybody else, okay? How about this guy? This guy needs a positive 2, because positive 2 plus a negative 2 becomes 0. So here's what I mean. First row, we're not going to change anything, okay, because we're going to do something with it. So leave that alone. Second row, how is it going to change? You're going to multiply row 1 by what? A negative 3, right? And you're going to add it to row 2 to get a new row 2. How about the third row? You're going to multiply this guy by positive 2 to R1, and you're going to add it to your row 3 to get your new row 3, okay? Stop the video at any time if you need to, okay? Let's do the math now. Negative 3 times this guy, negative 3 times this, you add this, you get a big fat 0. What's negative 3 times 2? If you want to keep your math in order, just do it here. Negative 3 times 2, and you add 7. What do you get? Okay? You should get positive 1. Okay, let's do it again. Negative 3 times negative 1, and you add negative 5. What do you get? You should get negative 2. Okay, negative 2, right? It's 3 and negative 5, okay? So remember, calculation is important, okay? Negative 3 times 3 is negative 9 plus 4. So it's negative 3 times 3 plus 14. What does that give you? It should give you a 5. So 5 here. Try to understand that, and then try the third row on your own right now. Stop the video. Try the third row. Did you guys get something like 0, 3, negative 5, 14? I hope so. Let's check, okay? 2 times 1 plus a negative 2, it's just 0. 2 times 2 minus 1 is going to be 3. Yay, okay? 2 times negative 1, right? 2 times negative 1 minus 3. Did you guys get negative 5? Yes, okay? 2 times 3, 6. Plus 8, which is 14. So check those values, okay? All right, now we're almost at this, right? Almost at row echelon form, okay? So now what should we do? Now what do we need? We need, this guy is 1, 0, 1, right? We need this guy to be a 0. That's all we need, okay? So what I'm gonna do is I'm gonna rewrite this like this. But remember, I'm getting a phone call, I know, okay? First row, we're not gonna do anything with it. Just leave him alone. Second row, we need to multiply this guy by -3 to add it to this to get a 0. So let's actually leave that alone, okay? And let's, because we're gonna do something with it. So now, what are you gonna do with it? You're gonna multiply row 2 by -3, right? -3 times row 2, and you're gonna add it to row 3. So let's see what we get there, okay? -3 times 1 is -3. This one just 0, because you just multiply by 0. -3 plus 3 is 0. Yay, okay? -3 times -2 minus 5 is going to give you -11. Oh, sorry, did I screw up there? Yeah, +1. +1, right? +1 there, because 6 minus 5 is 1. Okay? -3 times 5 plus 14, right? Which is going to give you, that's -15, -1. So that's -1. Okay, we're going to stop here. Why should we stop here? Because this guy is ref. And that's what the instruction said. You gotta follow the instructions. If I give you specific instructions like solve using Gaussian elimination, you have to stop and recognize Gaussian elimination. You see how you have leading 1s here and everything below is 0? That's what you need, okay? Now we can actually solve from here the way you know how. So here's what I mean by that, okay? Try this. You guys, let's rewrite this. Remember how, you know that this 1 here, you see how these guys were all x values, y values, z value coefficients, and the constant? It kind of corresponds to that. This guy is still your x, which means if you were to write an equation, don't you get something like, I'll write it here, okay? Are you ready? Isn't this really 1x plus 2y, 1x plus 2y minus z equals 3. You write the next ones now. You're right, no x, 1y minus 2z equals 5. How about the last row? Z equals -1. Oh my god! Look, you guys, you've already solved z equals -1. Ah! You've already solved it, okay? Because remember, our goal is to solve for x, y, z that makes this true. I want to find x, y, z that makes all these 3 equations true. That's what ultimately our goal was. We've already found z, okay? But now, you guys, don't you see why this is like all you need? You need REF. You can use back substitution. Here's where the back substitution comes in handy. You're going to use this value here and plug it into this equation to get your y. So what's y minus 2? Z is -1 equals 5. You're right, y is 3. You're done with x, y. Remember, you guys, you need x, y, z, and you've already found your y and your z. Let's find your x, okay? Now you have all your values here to get x. So x equals 2 times 3 minus a -1 equals 3. What do you get? X plus 6 plus 1 equals, you're right, it's going to equal 3, right? So x equals -7. Sorry, x equals -4. What am I talking about? It's 7 here minus 3, so x equals -4. So you guys, x, y, z is your -4, 3, -1. You guys, it's a kind of a pain in the butt to solve a linear system with 3 variables, right? So matrices, when you get really good at it, it's going to become so much easier for you to do. Okay, so that's how you solve that. So you have this is solving a linear system using a matrix in REF using Gaussian elimination and back substitution method. So I know it seems a little bit long right now, but I know you're going to like it later, okay? So stop the video if you have to and try to digest that a little bit better. Because next video is going to have Gaussian Jordan elimination, okay? All right, so watch for that. Sorry the problems are a little bit long, okay?